Thank you. Today I discuss about refractive index. Refraction means the bending of light when light travels from one medium to another medium. Here this is the first medium and this is the second medium. When the light travels from the first medium to the second medium, it bends. This phenomenon is known as refraction. Here it is the incident ray, this is the refracted ray, and this is the normal, and it is the plane of separation, and this point is known as point of incident. According to the first law of refraction, this incident ray, refracted ray, and the normal, all these three lie in the same plane. According to the second law, also it is known as Snell's law, for a given pair of medium, for a particular color of light, the ratio of the sine of angle of incident to the sine of angle of refraction is constant, and this constant is known as refractive index of the second medium in respect to the first medium. Sin I by sin R is equal to refractive index of second medium in respect to the first medium. Here I is the angle of incident, R is the angle of refraction. This refractive index is indicated by a letter mu. Here mu 2, 1, refractive index of second medium in respect to the first medium. Now for example, now the light travels from air to water. That means first medium is air, second medium is water. Then the refractive index of water in respect to air, it will be sin I by sin R. I is the angle of incident in air, R is the angle of refraction in water. So sin I by sin R, it will be refractive index of water in respect to air. This type of refractive index is known as relative refractive index. Now take us another example. Light travels from vacuum to water. Then it will be the refractive index of water in respect to vacuum. Then sin I by sin R, sin I by sin R, it will be the refractive index of water with respect to vacuum. And this refractive index is known as absolute refractive index. If the light is refracted from vacuum to another medium, then the refractive index of that medium is known as absolute refractive index. Here it is the refractive index of the water. If the light refracts from vacuum to water, then in that case the refractive index of water would be the absolute refractive index of water. Now refractive index also defined as the ratio of speed of light in first medium to the speed of light in the second medium. Refractive index of second medium with respect to first medium will be defined as the speed of light in first medium divided by speed of light in the second medium. For example, say light travels from air to glass. Here air is the first medium and the glass is the second medium. So refractive index of glass with respect to air, refractive index of glass with respect to air is equal to speed of light in air divided by speed of light in glass. At the numerator it will be the speed of light in the first medium divided by that means in denominator it will be the speed of light in the second medium. Now the refractive index, it is the ratio of two same type of physical quantities, and that is why it has no unit. That means refractive index say it will be absolute refractive index or it will be the relative refractive index. It is a pure number, it has no unit, like as the speed of light refractive index of glass, absolute refractive index of glass is 1.5. This is a pure number. Now the refractive index is a constant, but it is a variable constant. Its value depends on three factors. One is the nature of the medium, second is the color of light, and third one is the temperature. Now how the refractive index depends on the nature of the medium. If the speed of light is higher in the medium, that means for the rarer medium the refractive index would be low. For example, say water, its refractive index is 1.25 and the speed of light in water is 2.25 into 10 to the power 8 meter per second. Here the speed of light is higher and here the refractive index is 1.25. For another example, for glass, the refractive index is 1.5 absolute refractive index and the speed is 2 into 10 to the power 8 meter per second. That means if the speed of light is lower, then the refractive index will be higher. Now the color of light. In the medium, refractive index of violet light is maximum, and for the red light refractive index is minimum, and refractive index for the other colors are intermediate in between these two colors, violet and red. That means violet have maximum refractive index and red has minimum refractive index. Now how the refractive index depends on temperature. If the temperature increases, density of the medium decreases. If the density decreases, then the speed of light increases. If the speed of light increases, then the refractive index decreases. So ultimately what happens? The temperature increases, then the refractive index decreases. Now the next video I discuss about the second part of the refractive index. Thank you.